So seismic activities are also the indirect sources which actually tell us that how could be the arrangement of our Earth's interior. Let's have some idea. Let's have some quick overview about the interior structure of our Earth. So what could be the possible arrangement of our Earth's interior? So based on those direct sources and indirect sources, what we can that Earth's interior is made up of several concentric layers. Concentric means that from the one center we have a different layers. From that one center we have different. So concentric layers are there. So these layers are formed because of the cooling of our Earth. I hope you remember that nebular hypothesis and that planetesimal theory and all other relevant theories which used to justify that how our solar system and our Earth could have formed. So the layers of Earth would have been formed because of the cooling. Now, the denser material which are there like iron and nickel, they move towards the central part, and the lighter material which are there, these lighter material or less dense material or silicate, you can say, the silicate were actually in the topmost part of our crust. And this part where we have these less dense or lighter silicate materials, that particular part itself is as what? Crust. Below the crust we have a mantle, and below the mantle we have what? Core. Core is also comprised of two parts, outer core and inner core. Okay, so this is how our Earth interior is look like. It is also based on that seismic study, based on that seismic activities we can. So here we have these three layers, three concentric layers of our Earth interior: crust, mantle, and how to see that what is that, solid, liquid, or what. Now, if we see, for example, I told you that here we have a Earth, and if you move from the surface towards the depth, so from surface towards the center, there will be an increase. Will be an increase in what? Density. When density will increase, as a result of increase in density, temperature will increase. And yes, density and temperature both will increase because of pressure. So when the pressure is increasing, density and temperature will also increase in the interior. And when you go deeper, they will enhance, they will increase further. Suppose if you are here at the surface, you will see a particular density, particular kind of temperature of rock. If you have some sort of depth at, let's say, 2 kilometers in our interior, you will see the different rocks in terms of their composition, in terms of their temperature. If you further deep dive, let's say at 10 kilometer depth from the surface towards the interior of our Earth, then you will see the maximum, possibly the maximum density of rocks which are actually being found on the surface of Earth. And beyond that, you can found pro max kind of densities, temperature, and pressure, specifically with respect to the rock. But as of the human capacities are concerned, we have dig up to a depth of 12 kilometer, which I have discussed just a while ago. So due to this, we can say temperature, pressure, and density, it will going to increase as depth increases. Due to immense weight, I told you that due to the immense weight of overlying rocks, pressure increases. And when the pressure is there, so due to the pressure will cause compression. Compression will cause what? Higher density and increase the temperature. Further, what we can say that the interior of Earth is divided into three layers. We have crust, we have mantle, and we have core. So when we are talking about the part of our Earth, so suppose Earth would have been a one, earth would have been a one, earth would have been a one part of sun or nebula, let's say, as per the theories. So let's say we have a earth in this way. We have a earth. I told you that here the rocks which are there, they will have a different density. The rocks which are here, let's say this particular part of it, they will have a different density, pressure, you can say. Here the rocks which are there, they will also have what? Different density. Here to move towards the further, so the rocks will have what? Different. So in order to divide these density zones, or let's say these same, or let's say equal density of rocks, we have what? We have these concentric layers. We have these concentric layers of our earth, and these concentric layers used to tell us a particular density pattern of rock, and this density pattern is further modified, and we used to give a name, for example like crust, for example like mantle, and let's say for example core. So it is basically the separation of those densities of rock. So our earth is like a rocky ball, and in that ball we have a different density. From surface towards the center, density will increase. In order to demark, in order to make a, in order to demark, in order to, we can say, make a particular density layer, we used to classify these density of rocks in terms of layers, concentric layers, and these concentric layers have been given a particular name, and they are the part of our earth's interior named as crust, mantle, and all right. So this is how we have a rocks, but because rocks are different in terms of density, temperature, and pressure, we used to give them name in terms of the layered wide arrangement, that is crust, mantle.